get more honor you retain for that.
We're back. And I am
very excited.
I am super excited because this is cool. This class is cool, and to be able to show you something theory-wise that I can now apply in reality makes it even more fun. And I'm just excited that you guys have been awesome, seriously. Like all of you, like I see all of your eyes and nobody's sleeping. And I don't care, again, for those of you that maybe are disappointed in what you got on your test, the paper test today. Come on, man, it's a freaking score on a piece of paper. Stay with me here. Follow me what I'm going to show you here. This is what it's about right here coming up. This is what it's about. Rob brought up a good point when you guys were coming back in from lunch, and that was one of the things that he struggles with is maybe being too analytical at certain times and having that cause snags and slow down your diagnostic process, if I can reword what you said. I understand that. One of the things that I would be stuck on, I'll just show it to you.
Is a big word.
Was that key on,
yeah.
Jeff? One of the things that I'm stuck on right now that we could do a little sidetrack, but I have decided not to. I'm making a conscious decision not to. I know the theory behind a MAP sensor says that in most applications, in fact, I've pretty much assumed all of them that use a MAP sensor that are speed density, is the barometric pressure sensor is non-existent. It's a calculated number that's based off of the MAP sensor. And so what happens is when you turn the key on, you get an atmospheric pressure reading. This is one of the characteristics of a MAP that I want you guys to learn. You turn the key on, you get an elevation reading by the engine computer, and then the computer operates its fuel curve, not fuel trim, it's fuel curve, it's MAP, off of the barometric pressure reading. So that's done, key on, engine off. I have a conflict in my mind, and that conflict is why is my baro not reading 2.3 volts like my MAP is, because it should be if that's the case. There's two options. One, it has a separate baro sensor. Two, I don't know, is the other option. And so what I'm, I guess, maybe addressing Rob in that question is, here's something I know for sure, and that's my MAP sensor's messed up. Here's something I don't know for sure yet about this baro reading. And what I'm saying to myself, I'm pausing, and I'm not going that way to the unknowns. I'm going this way first to the knowns. And what happens more time than not is that will address itself within what we know. Experience will guide us that way, Rob. And my over-analytical mind, which has been intensified from teaching because I'm always thinking beyond what maybe a normal fix-it technician would think, has become a snag at times. It's actually become a detriment to fixing the car. So, not sure if that's gonna help the rest of you guys too. We run into this. I run into it all the time. If you watch my case studies, you'll see me mention something and say, you know what, I'm not sure about that. I'm gonna go here first, and then what will end up happening within a video or a case study, I'll forget to even address that question because in my mind it's already resolved, and I don't even bother to explain the resolve part of that variable. So just a little bit into that. Okay. I thought a few ways that I can do this. One is a lengthy, not too lengthy, but one is the drawn out process of let me teach you the map and the circuit and what I'm going to do. And another one would be, and I need to do that, we have to do that, so that's not a debate. But I kind of wanted to show you how quickly this can be diagnosed too. And I was thinking maybe I do the motions and not really tell you what I'm doing and show you how quickly I can identify if I have a wiring problem or a MAP sensor problem. I haven't made the decision on which way I want to go with that. I want to hear your feedback on that. So in other words, let me show you how fast this can be done, and then let's back up and show you how the step-by-step testing is. Or we just do the step-by-step and then we do what I just mentioned first, we do that last. Thoughts?
Do it first and then back up.
Yep.
Because I like, that was my first thought, because I want you to see what my thought process is. If I'm in the field and I'm going to troubleshoot this MAP sensor, I'm about to plug in 2 hours worth of theory, right, in about 2 minutes, if that makes sense. So how do I show you both the scan tool and that together while you're sitting there? What's that?
Clone yourself.
What I need is a second live camera feed and a second screen that you guys can see that on. That would be sweet. But I have a camera going over there, but you can't see. No, I don't have that one going yet. Let me turn that one on. This one will not help you right now. Let me just do this. You guys don't need to get up for this. There's a 3-wire pressure sensor that's sitting on top of the intake manifold. That's my MAP sensor. There's no hose on this one. So it's directly mounted. There's a hole drilled in the manifold, okay? I'm just watching my MAP data PID right here. Watch this guy right here. I'm going to unplug it and make a determination of something, possibly. Okay, no change whatsoever. And the next thing I'm going to do is I need to crank it to get an RPM signal. I'll explain this why in a minute. Still no change on the map. Did not expect that. I'm going to leave the car run. I guess for this part, if I'm relying, guys, listen, if I'm relying on ScanData PIDs to change for me when I'm doing troubleshooting, some ScanData PIDs need to have an RPM signal to get an update. The map is one of them. So the rest of this test, I'm not doing with the key on, engine off. I want the engine running for a reason, okay? I'm doing some real quick voltage measurements coming up. It's a 3-wire sensor. I just want to get a gauge on what I have. Should be a 5-volt ref, a signal, and a ground. I'll explain this to you in a second, and I'll give you the result of what I'm doing. I normally do this test plugged in. I just want to gauge what's on my map right now. I'm doing it unplugged. There's a 5 on that wire, there's a 1 on that wire, and there's a 0.02 on that wire. All right, so I have a conflict now. Can I show you this in 5 minutes? No, I can't. Let me shut this off. Could we be looking at BS data and that we're barking up the wrong tree the whole time? It's possible. I'll let you know here in a second. MAP sensor operates off of a 5-volt reference circuit. I have to alter this. This isn't going to be the 2-minute one because I'm not familiar enough with that signal circuit to do the jump test I want to do. That's my next step. I need a wiring diagram to do that, and we'll have to draw this out a little bit more. So we're going to pause with the kind of quick method. I'm going to walk you through this maybe as quick as I can, back up through the detail. I don't know. The hard part about doing this live is which way do I want to take you. There is not one way to do this. That's the conflict within my own mind, is which method do I want to show you? I can show you, I mean, ultimately I'm going to show you every one that I know. It's right now in front of you live. Which one am I picking? I want to verify map sensor, wiring, computer, okay? That voltage never changed. Don't like that. You mentioned O2 moved or something, Tom. What did you see change when I What?
Yeah.
Throttle position sensor.
That moved when I unplugged the map.
14%, 15%, down
Did
to
it?
2-3%.
Nice, okay. One of the things I was thinking about in between this is this had an engine put in it. And is it possible that we had some connectors that were reversed and that the TPS is plugged into the map and the map's plugged into the TPS? If that's the case, then if my TPS, that's a good observation. I'm going to give you credit for that because I didn't see that. And you mentioned it and I heard you, but then it was kind of a...
In one ear, out the other.
Yes, I apologize. I do that often. You know what I found in editing too is someone will say something and while I'm editing, I'm like, oh, that's a good comment. And then I'm listening to myself, I'm like, you dumbass. Did you hear what they just said? He, she, right? I was, anyway, my fault. Watch the map.
I've watched for that.
Okay, a MAP sensor, guys, listen, if that's the case, a MAP sensor is a pressure sensor, right? Measures pressure changes. If I would go over here with the engine off and open and close the throttle, should my MAP voltage change? No. No. I'm going to do that. Well, we might need an RPM signal, but watch the throttle. We're done. This car is fixed. Switch the MAP and TPS sensors around and
Really?
yeah. Really. Nice job. Exactly. You didn't see that? That was exactly. You saw it. I missed it.
Like I said, I have.
It was kind of it still was a 2-minute test. I'm going to back up to, if we didn't see that, we kind of played devil's advocate, and if we didn't see that TPS, this is still a great case study, and you just don't see that every day.
How it's gonna run? I kind of
Well-
want to hear how it's.
Well,
gonna
here, let's back up. Let's back up to what I said before lunch. Do you remember I said that most of the time we have a MAP sensor that, sorry, I'm distracted. I was just thinking about the baro, and does that explain the baro too? And that's what I was just thinking about. But anyway, this is the way this works sometimes. Your mind runs faster than your mouth can speak. And anyway, before lunch I mentioned when you have a MAP sensor that's reading load conditions, wide open throttle, at idle, that generally it'll run good under a load, but not at idle. And I said this one's not reacting that way. Well, of course it wouldn't if the TPS is the MAP and the MAP is the TPS. The MAP signal's never moving. The resistance value of the TPS is off compared to the MAP sensor, so it's reading a load constantly. Wait, am I getting that right? I don't know. I have to figure out TPS and MAP, which way's going where. But as I accelerated, I didn't notice that my MAP voltage was going from a load to dropping instead of the other way around. We could say it that way. That's why it wouldn't take fuel. It was not a steady, rich, steady load condition. As I accelerated, load would have dropped. All right? Because watch when I open the throttle, voltage is going to drop. That's not how the TPS works on this, right? So the lower the MAP voltage, the lower the engine load, not the other way around. And yeah, it's just I don't know if I can fully explain the two circuits and how they're operating without confusing you right now.
They correlate directly, where the higher the voltage, the higher the load.
Let me do this. This is.
Inversely, where the higher the voltage load.
I think I heard you. I probably will want to hear you when I'm editing this. Say that again.
They correlate directly. The higher the voltage, the higher the load.
Correct.
Instead of inversely, which would be
Correct.
higher voltage.
And that would be for both sensors. Both sensors should be operating that way. And the reason the MAP voltage would be dropping is just because of the wiring design of the TPS is different from the MAP, and that's what's causing that. It's not that the TPS voltage would start high and drop low on this vehicle. It's the other way around. Do we have TPS voltage, or are they only giving us percentage?
There it is.
Sweet. Let me plug this back in for a second. I just want to see. So here's what's crazy. That's almost a normal TPS idle voltage reading, that 0.82. Think about this. There's no fault codes in the system at all. That's kind of crazy too, right? So let's just look at, this is where I would custom data display this.
And it's just accepting that.
Yeah.
It's not saying, whoa, something seems
It's
wrong.
not doing any rationality. It's yeah.
All right, you must have plugged it in right. I accept that you plugged it in right. I'm reading it wrong.
Yeah. Let me say this before I get lost in everything that I'm thinking about too. Where's my baro at? Baro volt. One of the things I want you guys to be able to do when you start troubleshooting is have this checklist in your mind of major kind of critical sensors that we want to eyeball. And this can be done very quickly, where we're looking at ECT, looking at IAT, that's engine coolant temperature and intake air temperature and manifold absolute pressure and throttle angle and barometric pressure. And we look at these and we say, that looks good, that looks good, that looks good, that looks good, right? So if we were to do that on this vehicle, ECT, that's voltage. I don't know what the conversion is, so let me, you're fine. Let me draw in the degree Fahrenheit for you guys. Okay. Because the voltage for the ECT, this 1.7 volts, within the computer's ROM memory would be a table that says 1.17 volts is 149 degrees. Now let me ask you guys this. Does that sound logical for the amount of time we had the car running? Remember, it was dead cold. We started it up. We had it running, not for a real long time, and it's now been sitting for over an hour. I think 149 degrees sounds pretty rational. So in my mind, I'm check mark, done, moving on, next step, okay? Intake air temp is 113 degrees. Well, depending on where that intake air temp sensor is, the engine can warm the manifold when the car is sitting still. That looks logical to me too. Check mark, moving on, next sensor. TPS, right? Looks like a logical idle reading. You'll learn that generally under 1 volt. So the next step for the TPS, we open and close the throttle, key is on, we look for a data PID change. There's wide open throttle, I let go, no change on the TPS. Red flag. Is that an actual signal? My next thought is that a substituted value? Can I rely on that? Different subject, but bad, right? Red X next to TPS. Moving on. Baro looks logical for a Honda. Low if this was a GM or Chrysler. ECT, IAT, MAP we need to address now, which we already have. Engine off is wide open throttle, heavy load, no vacuum, high atmospheric pressure. My MAP voltage right now should equal my Baro. Should equal the Baro. They should both be reading about 2.79 volts. And when I start the car, MAP voltage should drop off immediately because vacuum increases, no load, low voltage. High load, high voltage on a MAP sensor. We good? So right from our initial checklist, we would have caught what? No fault codes. We would have caught TPS and MAP. Cool? So that was a point I needed to make. And I apologize for being seemingly scattered in which direction I want to take you. I think test results dictate where we're going to go, okay? Let me show you what stopped me first before we continue. If I have a data PID here, which I do, this MAP, that was my multimeter. This MAP data parameter did not change. My first thought is wiring or sensor. I need to confirm wiring. The wiring is good before I condemn the sensor, okay? So what I was attempting to do is take this, is this gonna let me draw? Not way over there. Do I have my USB plugged in? Yes. I did calibrate this, didn't I? I thought I did. Let me just do it again. This car's been sitting here for 2.5 months for two reverse connectors. That sucks.
Sorry.
That's, oh, come on, man. Give me some love. Nice. Okay.
I think it was drawing you black.
You know what? I forgot. Well, you're right. Yeah. Hold on. Okay, Tom, I'm just going to hand you the marker. You come up and teach. Listen, there's a reason I was drawing in black over black. I programmed my computer that black is yellow. And I forgot that I'm on the Verus now, which is a different platform. And so Tom is correct. Black is black on this one, not yellow.
Haven't you heard? Orange is going to be black.
So Tom is on it today, and I am not. Thank you, Tom, for correcting me again. All right, so look, focus with me here. MAP sensor signal voltage isn't changing. Where are we getting this signal? Let's get the right perspective. We have an engine computer, the ECM, that is feeding information to a scan tool, okay? And this MAP voltage that I'm seeing here is processed data, okay? Where's that signal coming from? It's coming from a 3-wire pressure sensor. And I'm going to draw it like a potentiometer, variable resistor, even though it's not, just for understanding circuit design, okay? This would be section 8. Instead of going to section 8 and doing it there, I'll just give you a quick design up here. Internal to the computer is a 5-volt reference circuit. It's a little 5-volt regulator that really is the heart and soul of the whole engine computer system. It's kind of I've often compared it to the bloodstream, of the human body. Like it's that 5-volt reference. You don't have this 5-volt reference, you're dead. Okay, it kind of runs everything. Memory chips and communication signals and everything runs off this 5-volt ref. Okay, steady 5 that comes out to. I'll draw this as a variable resistor. So this part here would move. This is a steady 5. This is a steady ground. Okay, and this would be my signal. Internal on the signal circuit is one of these guys, and you guys that are computer gurus can help me with that guy. That is what I'll draw in here as a voltmeter, voltage sensing circuit. That's how I've described them in the past. I've also said that came from the Allspark. So we'll just leave that alone, right? That's where that chip came from. Who made that chip? Aliens made that chip. It's the source of all life. Anyway, internal. Here's the perspective you guys need to have on this potentiometer circuit. This signal wire does not in any way, shape, or form carry current flow. Okay, there is current flow, even though it's in the microamps. Because we need to have a voltage drop on this circuit. So we have a steady 5 traveling this way across a fixed resistor on its way to ground. This is not exactly how the MAP sensor works, but this is how we're going to think about it. Okay? And across the resistor, we have that Kirchhoff law takes effect, that the sum of all voltage drops in a circuit will always equal the source. And if we only have one resistor in the circuit, we can be sure we're going to drop this whole 5 across this resistor. So by the time we get to the other side, this should be near 0. Now we're given a tolerance, and that tolerance you guys want to remember, this will be on a test, not necessarily the one coming up, but on sensor circuits, we're looking for less than 100 millivolts. And the reason we're given that tolerance is this ground circuit has some resistance to it too. So we're not truly dropping all of the voltage across the resistor. There will be some remaining on that ground circuit with a tolerance of 100 millivolts. Okay?
So 1/10 of a volt is our...
1/10 of a volt or less, that would be 0.1 of a volt or less is acceptable ground voltage on a sensor circuit. Most of the time on a good one, Tom, you'll see 20 millivolts. 0.02 would be a typical ground reading on a sensor. Okay, and when we check that ground, we want to be plugged in to check that ground. Loaded circuit, ground to ground. We'll get more into that.
Have you found any exceptions to this through any manufacturer?
Yes. Yes. Some sensors use a bias voltage on the ground, and voltage will be elevated intentionally to pull us off the noise of the block. It's called a floating ground. And we will need to talk about those too.
What section is this technically?
Everywhere.
That'd be a problem.
Well, you can't give me, I need a heading. My notes.
What I'm describing, that's a good question. Jackie wants to know what section we're talking about, and I just said everywhere. This would be, what I'm describing right now would be more a potentiometer, which would be chapter 7. However, we're using this in relation to a MAP sensor, which is chapter 8. The reason I'm not going through the MAP sensor is the MAP sensor has one of these inside of it that does this stuff in here, and I can't walk you through how it does that, if that makes sense. So when pressure changes a piezoelectric crystal and it produces a weak AC voltage, then it's interpreted by a analog to digital converter, and then it's processed, and then it converts the signal, and that's why I'm not doing the MAP.
I don't know, that makes sense to me.
Okay. Crystal, pressure this side, pressure on that side. That's only one way it's done. Ford does it that way. Other ones use a flexible silicone, if I'm saying that right, silicone diaphragm, that as the diaphragm flexes, its resistance changes, and it's a more simplified version, and it works similar to this. But rather than it being a movable resistor like a wiper moving on a slide like a TPS, it is a flexible diaphragm. Sorry.
That doesn't actually generate the voltage directly.
Correct. It modifies a signal.
Whereas piezoelectric crystal is actually generating voltage.
It is, but that part is used to modify the signal. So.
Using electricity to modify electricity.
Yes.
Sweet.
All right, so listen. I don't mean to lose you guys here. In a few short measurements, I made some determinations on this car. What we need to do is we need to visualize this when we have a signal that doesn't change. What should it be doing? This signal should be low voltage here if you can picture it. Why would it be low with this pointer in that direction? Most of the voltage has dropped. So if we're down here, voltage is low. And as this moves up, voltage will rise. This is how a TPS is supposed to work. This would be similar to how a MAP works. If my signal doesn't change as I'm moving this up and down. Now, how was I moving this in our MAP sensor? I was not moving the throttle. I realized I was moving the throttle, which kind of throws a monkey wrench in this whole thing. But in reality, what moves the MAP? Signal voltage. Pressure. So how was I changing pressure? I was going both extremes. Engine off, wide open throttle, full atmospheric pressure. I realized we weren't at wide open throttle, but what kind of pressure is in the manifold at wide open throttle? Atmospheric. So I was showing wide open throttle pressure, no change. I was showing idle pressure, no change. Was I moving the quote wiper for the MAP sensor? Was I doing what was necessary, that's what I meant, to move the piece in the MAP sensor? Yeah, so it looks like a bad MAP. So some quick voltage measurements, see if this makes sense. Come down here, I don't know, can you guys see red okay? Or is green better?
Red.
Okay. I disconnected this with the intent of doing some signal circuit tests, and I'll gauge that for you in a minute. I read 5 volts here. As I'm watching the scan tool staying at 2.3, it never moved. I read 5 here, 0.1 something, 1.8 here, and really it was like 0.0. And I'm pretty sure that was the wiring. Here's the thing. What I see on the sensor doesn't match the scan tool. And when you see that, you have either a wiring problem or a computer problem, not a sensor problem. So right there is where I paused and I said, okay, I can't show you the quick methods I want to show you to verify wiring integrity. We're going to need a diagram. And then somewhere in there, Tom's like, I saw the TPS move and I heard O2 the first time you said it, not TPS. Totally disregarded him, but he was right spot on. That makes sense where we are? Mm-hmm. All right, so a couple lessons here. You see voltage live that doesn't match scan data. You have a wiring or computer problem in most circumstances. Now, herein lies variables. I mentioned a couple. Sometimes you need an RPM signal for a data PID to change. So you're down here manipulating the circuit looking for a data PID to change over here on processed data, and the computer program is saying, I'm not changing that PID because nothing's happening right now. Why would I update the MAP data PID when the car's not even running? I already got my baro reading. I'm not even looking at that MAP sensor right now, if that makes sense. That's why I left the car run. Needed that RPM signal. Another one, I have a chapter in, I'm not going to do it right now. It's called substituted values. I have a whole chapter in my book designated to substituted values. This is things that can throw us off in the future. Sometimes a computer throws in a default value that it knows there's a fault in the circuit and is using a default value and will not change that value no matter what you're doing to the signal circuit. Is everybody following what I'm throwing at you here? This is really why you don't want to miss a day in this class. All of this ties together. All of this will mesh eventually. When it meshes, for everyone is different, but when it does, it is like that. It is like, oh, that is so simple, you know? Sometimes they can throw you off. All right. I want to refer now. I want to show you what I wanted to do here. What I wanted to do, well, I could just stay here. I was going to take you back to my book. What I wanted to do, see if this makes sense, is I wanted to jump the 5, with this unplugged, my next step, I wanted to jump the 5-volt reference to the signal wire, which would have driven 5 volts in this direction, and I wanted to see scan data change to 5 volts. If I saw that, what would that tell me about the integrity of the wiring? It's good. That's what I wanted to do. That's what I wanted to show you. But there was a question of this decimal here and this decimal, and which one was the signal and which one was the ground. And if there is any question in that, you would not want to jump the 5-volt reference to ground, and I wasn't going to do that test anymore. I had to stop. I needed a wiring diagram. There's another method, and this one I will take you quickly to my text because it would be easier than drawing it. This is in section 7, and I apologize for jumping around. I'm really not, in my eyes, this is all tying together. I want to talk about some different circuit designs here. Internal designs. Now, this is the part I say can be a little bit lengthy. I'll do this quick because we're not really here, but this is what I wanted to do on this car. I have 2 different types of potentiometer circuits. I realize it's not a potentiometer, but use it as a guide. Use it as a visual. It works the same way with a MAP sensor. I want you guys to notice what you see different about these 2 circuits. What do you notice?
The way the arrows are going and place normal, key on engine off,
Those are, that's just pointing to that one. This is one design, and this is just pointing to that. There's the other design.
Why is the bottom one more detailed than the top?
The bottom one has a 100 kilo ohm resistor.
I have an extra resistor here is what's different. This is internal computer design. And this is an assumed value, guys. I am not totally sure about that value, okay? So what we have here is 5-volt steady coming from the regulator on this line, and I am not going to be able to draw because I'm connected to that. 5-volt steady coming this way, okay? And picture this wiper as, you know, being in that position or being at idle or reading 0.45, and they're both the same. So 5 volts coming this way, same thing here, but I have another path for this 5 volt to run, which is across a very, very high ohm resistor, and it's really having no effect is my point with this drawing. It's having no effect on the signal circuit at all. As I would accelerate this one, this voltage will rise, feed back into the sensing circuit, no problem at all, okay? When this resistor comes into play would be, I don't have control. It's what happens when you use multiple computers. When this would come into play would be when we disconnect these circuits. These are normal, guys, normal, disconnected sensor readings. A circuit that does not use this resistor, 500, very similar to what I saw on the Honda. 5.180, close enough to 500. A circuit that uses this resistor unplugged, we see 5, 5, and 0. Where's this 5 coming from? It kind of contradicts how the sensor works. You know, we said it feeds a signal back into a sensing circuit, a high resistance sensing circuit. I'm controlling this as I'm touching that. Why is this reading 5 here? This 5 volt has a path nowhere to go over here. It goes through this resistor. This is not a path for current to flow. It has nowhere to go over here. So with no ground, with no end line, that 5 volt stays 5 volts. Where is it going when the connector's plugged in? I know this is difficult, but hang with me on how I'm going to use it. Where is that 5 that's coming across the resistor here? I hate that tool.
It's not going across that resistor because it's got a lower resistance to the 5 kilo ohm resistor.
It still is, it's going this way. We're getting our drop here, but anything that's coming through here would be bled off this way to ground, right? And that's right. It's higher ohm resistance, lower ohm resistance. This one is actually finding a ground through that resistor. And it's so high of resistance, I might be off on that 100K number. It's such a high ohm resistor that it will not affect the circuit. And if it does a few tenths of a volt, the circuit's calibrated for it. Okay? Now, how can we use that to our advantage? Think about this car. Think about what we have. If I have that resistor, let me switch back to this. Everybody having fun? This is cool.
Would that be why our map wasn't budging on 2.3 volts?
No, our map wasn't budging because we had the TPS and we figured that out. But hang with me here. Here's what my thought process was. And can I fix that without too much difficulty? Let's see if I can. Draw this back in here, and this one, and my ground. Here's what I was thinking. My first thought, I'm thinking about what? Does this car have an internal resistor? Can I unplug the sensor to verify circuit integrity? Because one that has it, it's as simple as unplugging this, knowing that it has one of these resistors inside right here. What should the signal voltage do immediately when I unplug it? Should go to 5. And I want to see my scan data change to 5. And if I do, how's my wiring? Okay, so that was the test I wanted to show you guys, like the live part. Wasn't able to show you. If I can go to a sensor, if that sensor was actually faulty, causing the 2.3 volts all the time, which I assumed it wasn't, until I saw it was a new MAP sensor. That's a new MAP sensor. It looks new. If that MAP was faulty, a simple unplug it test and that going to 5 would tell me what? That sensor, it has an internal resistor and also would tell me that my signal wire's fine, reference circuit is fine, most likely bad sensor. One more check your ground voltage, make sure you're low on your ground. Because if your ground voltage, if you have resistance on your ground, won't that cause pressure to back up this way? And won't that cause my signal voltage to rise and be abnormal? And couldn't that cause this too? Yes and no. Yes, in that it would be elevated, but no, it would not be steady. We'd still have some function to it as it moved. It would just be out of range. Lots of thinking, but really, really easy to use. Questions? You don't even know what to ask me, do you? Did I confuse you?
Can we switch those connectors and start it?
Absolutely. No, before we switch the connectors, I want to look at them again with them reversed and our fuel trim numbers all together, if that's cool. We can't look at trim, can we? On our factory data, we can't look at trim. All right, we'll switch them here. No, we'll look at it live here, screwed up, see what it looks like. And then we'll switch them, see what it looks like, see how it runs. And then I'll switch them back. We'll go to generic data, look at our fuel trims, and then switch them again and see the counter fuel trim corrections. And then we'll take a break. It's real quick.
Sounds good.
Okay? I'm just having a lot of fun. This is really cool. Thanks for helping me out, Tom. I am plugged back in. Can you start that for me, Jeff? Let's watch our map and our TPS. All right, so why is the car idling okay? Because that's pretty much close to being a normal TPS reading. And it's running rich because that's a load condition. 2.3 volts is a load, so computer's adding fuel. And I believe it starts to run better as it warms up because now the O2s come into play and fuel trims start to counter that additional fuel that we didn't need. But watch these two as I snap the throttle. What should happen is this one should rise and this one should rise as I snap the throttle. Now remember, the car is going to die if I snap it too much. That's pretty cool. What we can do is we can zoom in on that a little bit to see a little bit more sped up process. Watch it again. Those were wide open throttle snaps right there. That was all we had. All right. Actually, I'll stall it. I just opened the throttle. All right, so now what we want to do is switch these two. How nice of Honda to make a the connectors the same, huh?
Yeah.
It's not easy to. I don't think I'm going to switch these back. You know, I said we're going to switch them back for fuel trim. It's just not all that easy to do. Okay, I switched the two connectors. There's my MAP voltage 2.7. I'm thinking we have a separate baro sensor on this car. Watch the key on engine off, open and close throttle now on the TPS. That's what it should be doing, right? Now here's the other thing. We have a 0.47 of a volt signal, and you guys will learn this too, and you pay attention to me when I'm talking. Everything I talk about is relevant. This may have a self-zeroing throttle position sensor value. So it learned the 0.7 number and now has to relearn the 0.4 number, and I may have some idling issues until it does. And I may have to do some things to correct that. I'm not sure. Can you start that for me, Jeff? I don't want to run it long. Wait. I think maybe you saw it. Well, you need to see the MAP voltage drop. Then stay right there. We'll shut it back off. I don't want the fuel trim to counter yet. I want you guys to see that. Start that up, but stay right there. Watch the MAP. That's our main focus. That's what we want to see, right? And then watch the rev. Watch the rev. Okay, good. Shut that off. Questions? Darn it. Didn't want to lose that data.
I tried that.
Yeah. Questions?
I guess that does.
Okay, so here's what we want to do, because I want you guys to see the trim numbers, and we can come back to that maybe. To see trim, we had to go, can we go generic functions?
Yes.
We can't. Where's mode 1? That's why it's called generic functions, not global OBD2. It's not the full list. I guess the reason, I don't know the reason, but I have data in the manufacturer mode. I guess they assumed you don't need the global data. They don't give it to you. I was under the assumption when I heard from Snap-on that this is a mode the government didn't want them to have this kind of access to anyway. In other words, they want you to back all the way back out and go in under global and not have some punch through hole that we can do it from the manufacturer side. Does that make sense? Now, I don't know if that's a Snap-on thing or if that's a manufacturer thing. Anyway, I can't get all my modes of global from here. How do I do it? We hit our home tab, we change our vehicle, we change our chip, we go back to OBD Direct. Our chip was a K20. I just want you guys to see these trim numbers. I hope they didn't drive this car long this way. Actually, they couldn't have, could they? There was no driving this car. They weren't driving this car. I was thinking about the cat. Maybe they melted the cat down, but I'm still getting them messages, aren't I, Rob?
Yes, you are.
I don't care anymore.
It's a different.
Maybe we'll untick, if we untick that other one, maybe.
It's a different message now, though.
It is.
Yeah, this one's. Yeah.
So we'll get rid of that other message too then.
I don't think that's what.
No?
No, you'll do it from there.
Oh yeah,
Do it from control panel.
that's right.
So
I'm not worried about it right now. Data, right? I would be awesome to show you the counter fuel trim numbers here. I don't care if it doesn't work. We fixed this car. Okay? Yeah. Thank you, Tom. I will give you 5 on that one.
$5?
5
A 5. I'll give you 5. We don't need to look at everything. We'll just look at trim, upstream. See, this has downstream trim. I almost want to see what that looks like. Now that we've learned a little bit more about our downstream trim and how much that can mess things up, right? The fact that this car is showing us a downstream trim, I definitely want to pay attention to that. We don't have MAP on here, do we? Our calculated load, we could, we almost had them all selected anyway, right? All right, watch my long term here and short term. Can you start that for me, Jeff? Our calculated load, we were at 70-some% before at idle. I expect that to be a lot less.
Oh my.
O2. Let's graph that guy. That's my upstream, and let's just watch these trim numbers for a second. That's coming down. Why? What's changing it? Right there. Did you see that? Where's my long term at? I'm missing it right here. Here we go. Pause. Perfect. I missed it.
You saw the 18.
Did you see it?
Yeah,
Hold on. Wait. Where was it? Come back. Did we fix this car? Let's let it run.
The timing advance definitely changed itself too.
Is this live? Why is it still frozen? It got
Because you're
it got stupid on me.
back on it. And on that slide where you're selecting what screen you're looking at.
Where's my short term? Positive 10, long term still minus 19. Is that going to come down?
Yep.
Now, the characteristics of when that does that are different for every car, but let's keep watching it. Should counter. Yeah, timing advance. So it wasn't cam. You mentioned a cam.
Yeah, I misread it.
No, that's okay. Do you guys understand why the timing advance was minus 10 before? Could have thrown us off. And after reading the troubleshooter, we were thinking maybe timing chain or timing belt's off. And, timing read minus 10. But remember, it thought it was under load. So isn't the under load timing map going to change too? And minus 10 is where that number came from. Maybe at that particular load and those conditions, that's where it wanted it to be. Starting to come down, isn't it? We're now down to 16. Let's watch it for a couple more minutes. And what I would want to see, guys, is this to be a positive 16. I'm not concerned. Here's why. Here's what I'm seeing on some cars. They're not weighted the same on some cars.
What plus? Aren't you at
GM, Chrysler, what's that? Sorry.
aren't you within the 10 mark?
Plus or minus 10, yes, this would put me in there, but my suspicions are that this is not going to be 10 when we're done. I think it'll be less than that, is my guess. I'm not sure. If they're weighted the same, which some cars are, most cars are that I've seen, they're weighted the same, meaning, take this away from that and you'll get your total trim. But I've seen some cars, they're not weighted the same. So maybe one of these is equal to two of those, if that makes sense, I've seen that. I think this car smells better too. We don't even have the fan running now. My downstream sensor's still reading rich. I don't like that full rich on that downstream. Although that might be okay if there's not a lot of oxygen coming through and it's catching and storing oxygen and doing its job. That can't really gauge that. This upstream one, we want to see this thing fluctuate, but I believe this is a wideband and this is a calculated number, and I don't think you're going to see the same kind of fluctuations here on this vehicle, because under the factory data it said AF. When you see AF sensor, AFS, that's an air fuel sensor, that's a wideband, and I don't think we're going to see the same rich lean we've been talking about here.
What kind of volt reference do they want on? Is it 5 or 3?
On the widebands, like 3.3 volts on the ones that I've measured. Let me raise the RPM a little bit, see if we have a memory change at a higher RPM. you see those positive 18, positive 17% with a minus 16? It looks like that number is going to be a while before it's going to come down. This might be one I'd wipe the memory out on. See what it looks like when I'm done. Wiping the memory out on this car might be disconnecting the battery, or I'm pretty sure it's not within the manufacturer. I could see. Now, you know what we'll do is I'll just, maybe we'll just let it run while we're on break and see what it looks like when we come back from break. We good with that? Okay, when you guys, on your way out, can you put that fan in the door? That way, I know, and open that door with the garbage can. Go take a break. We'll look at these trim numbers when you come back and get some final thoughts. Okay, listen, I have a few things I want to talk about to sum this up. And one of them is, you can see, guys, look where we are as far as our trim numbers. And when you guys went on break, we were about 100 frames of data in, and now we're 330 frames of data in, and we're getting pretty close. And I think you guys can see what I'm talking about now by the weighting, and I think maybe we need to consider total trim. I told you guys is the sum of long-term and short-term, and that is the case, but I think there's a variable here, and it was the variable we learned earlier with the downstream fuel trim. I believe the cars that have wideband sensors are the ones that have the downstream trim, and this car has downstream trim, and I think that that's when the weightings changed between the short term and long term. In other words, when you guys left for break, this was minus 16 and this was only 7, and I said, I think when this is done, that long term's, you know, if you did the math, what's that come out to? Minus 9. Well, look where we are right now. We're at minus 3, and this is still adding fuel. So guess what? That's going to come down even more. So what's that tell us? Our total trim, and what I told you, there's a variable to that. And I'm saying that variable may very well be the downstream trim is a factor in there in the weightings of these, if that makes sense. It's not critical for troubleshooting. It's just an observation that using the counter fuel trims to say this car is fixed might be a variable to that I think I've known about all along, just never really thought about it. And what I would do when I see a discrepancy is what? Scrub the memory and then start the car and make sure my trim numbers look good. And when they do, I'm good with that, right? But anyway, questions on that part. I think it's a good lesson here. We're still dropping on the long term. Everything looks good to me. I think when this is balanced out, it's going to be a little bit still, but I think these numbers are going to be great. Yes?
Do you think long term for higher RPM settings will be still skewed?
No, I don't. In fact, I think what we'll end up seeing here is probably a positive 3 on the long term, possibly somewhere in that area when this is done doing its thing. Does that answer your skewed in what way? I'm not.
As you go further into the fuel map, like higher speed, higher RPM.
Gotcha. I misunderstood. Well, yes and no. Yes, if the car was driven under these conditions, it would have learned to those. But no, because the car couldn't have been driven.
Right. There's no way to reach those RPM without it falling off.
Yeah, exactly. I think if I change it, we'll see a little bit. It'll be off, but I'm not going to worry about that. They drive the car, it'll be fine. We'll exit out of this mode and see if we can clear the data through the factory mode. We'll see if we can do that. If not, I'm not disconnecting the battery. I don't care. We have one more piece. We have a check engine light on that we didn't have before. So I want to look at that light real quick. And it could just be because I had the TPS and MAP unplugged that I set those fault codes, and we did have the key on, and that's my guess that those are codes would just wipe out and be done. One other thing to point out, this is not a narrow band upstream O2 that we're looking at. This is processed calculated data off of the wideband is what my guess is, and this is kind of giving you an idea of that same rich lean moving back and forth across stoic is not being done the same way on the wideband sensors, and it kind of backs up what I was telling you guys about why it's done. If it's done primarily for converter efficiency, then why aren't we seeing it here on this wideband design is a valid question. Okay, I'm gonna go back to the factory mode. We're gonna look at codes, and then let's take a peek at that air-fuel ratio number just to see what it looks like. I'm cool with this. I think we're gonna be a little bit on the positive side when it's done, and I think the weighting is a little bit different on this design because of downstream trim. Okay. Home, change vehicle, change my chip. I put the K24 key back in. I'm going to vehicle history. Maybe. Honda, activate. Should come up down here. Scan tool. K20. That's trying to do that automatic ID again. I should have hit cancel right there, not continue. MAP and TPS is my guess. So we set a rich code. I think that's going to take care of itself, right? I don't know if the car was, why it didn't flag that before. Interesting that it didn't flag a rich fault before. Well, remember the parameters were all screwed up.
The map was reading heavy load, therefore rich condition would be expected.
Who knows? I mean, yeah.
Just my guess.
Yeah, no, it's a valid guess. But remember, TPS was plugged into where the map was plugged into the TPS, so our load calculations were way off, and you know, under that scenario, yeah. All right, we can wipe these out, would you agree? These aren't coming back. That's why that light's on. We'll do that. Fuel metering out of spec, that's a fuel trim code. Under my functional tests would be where we get this reset stuff. Any reset stuff in here?
PCM reset.
Where? Ah. Yes. Probably need the engine off. Turn the key back on. Automatic. What are we resetting though? DTC and freeze frame data will be lost. Yes, I want to do that. Continue. So cool. We don't have to disconnect the battery to wipe out the stuff. I would have to go back to global to show you the long-term trim, and I'm not going to do that. That's just how it's done. Some vehicles after reset idle may be low or erratic until PCM learns proper idle. IAC learning occurs if you allow the engine to idle at 10 minutes normal operating temperature. So if it starts and stalls a couple times, I'm not going to panic. That's pretty cool. O2 test, that's cool. Data, just wanted to see what our factory data gave us. Air fuel feedback, air fuel average. Giving us a value of 1. On some of these, that's lambda, which is 1, which is ideal. Lambda is 14.7 to 1. I don't know the correlation with that term. I apologize. That's Greek, isn't it? Isn't that a Greek? Calculated load, that's that one we were looking at before. That looks a lot better, doesn't it? MAP and TPS. Do they show me my downstream sensor? Those are the heaters. There's my downstream voltage. Yeah, it really doesn't show me anything other than this value here. So I don't remember how the lambda number works. If it's numbers above 1 and numbers below 1, which way it's rich and lean. I'm not totally sure on that. Numbers above 1 would be rich. Numbers below 1 would be lean. So it's opposite of like what we would see with an O2 signal. And again, that's a calculated number you're looking at. You guys need to understand this wideband sensor. We don't have any voltage readings on this wideband sensor at all. You're looking at completely processed data. It did have millivolts, didn't it, for milliamps? Didn't we have an upstream like milliamp number? I thought I remembered seeing that. There's the heater.
No, it's off.
Is it?
Yeah. Higher than 1.
Yeah, the
Higher than 1 is lean,
because that means
lower-
it's still trying
lower than 1 is rich. There it is. Wideband sensors operate off of milliamps, HO2S1. So the theory states that the milliamp still swings up and down. I'm curious right now. I want to see that. I'm going to raise my RPM a little bit. Well, there's your wideband rich lean. So it is moving it up and down, but it's a milliamp number, and you'd never see that on the car. This is all scan tool stuff. Some of the stuff I've read about wideband sensors is scan data is really your tool for diagnosing these. It's not so much looking at them voltage-wise, because voltage is steady. It doesn't move. It stays at 3.3 volts all the time. And it's a milliamp number that's changing underneath that you cannot see unless you have a very, very, very low amp probe or you're doing direct measurements, because that is a tiny, tiny number, isn't it? It's operating in a very, very small window. I have problems reading 100 milliamps with my amp clamp, let alone 5 milliamps, okay? But this car is fixed. Is there anything else we need to see? MAP and TPS again, one more time? Are we good with that? MAP voltage?
TPS was down on the right hand side as well.
TPS percentage.
There it is.
MAP, TPS, a little quick snap throttle. Cool. We give this back to this guy now, I think. Did we miss anything? We did. One other piece, and this is not on the car. This is for you guys when you go out in the shop. This is your don't danner me to death last piece, okay? We had a MAP sensor fault, right? TPS fault, whatever. Hit your home tab. There's more help this tool does for us. The component, the guided component test, this is your Snap-on Vantage Pro. This program right here is the Vantage Pro. In here, in the guided component test, this is what I should have told you guys before, but I gave you my version of testing the MAP. US import. Do I want to load this? Yes, I do. I want to go under my fuel injection system. Notice we have ABS, charging, and transmission. Fuel injection. I want to pick my MAP sensor. Where's my MAP sensor?
Right hand column, third one up.
Thank you. I was going to say, there better be a MAP sensor on here. In the MAP, we got component info. What do we do with component information? I'm going to shut this car off. Component information. This is, listen carefully. This information that you're looking at right here is unique to this year, make, model, engine car. This is not generic. This is this car. MAP's a 3-wire sensor, measures pressure as PCM uses MAP to help determine load. As MAP manifold vacuum increases, MAP signal decreases. As manifold vacuum increases, MAP signal decreases. MAP signal is used by the PCM for calculating injection pulse width and timing. Location, best test location is at the connector. We're going to test it. Where's it at? It's mounted on top of the throttle body. That's the connector. These are the pins. These are the wire colors on the pins on this car. Tech notes: repair vacuum leaks. Check before checking the MAP signal. Low manifold vacuum is caused by tight valves, incorrect cam timing, or engine mechanical problem. Great tip, right? Go back. Go to the DC voltage test. On the DC voltage test, it gives me the same connector. Tells me where to connect my test leads. Yellow test lead will go to the MAP signal wire. Well, which one's the MAP signal wire? You find the connector, find the tab on top, viewed harness side back probing if they didn't give you those colors, and I would know that pin 3, looking at it on the back side, would be my MAP signal wire. Back probe that one, it gives me color, that's awesome. Black lead goes to a known good ground. Key on engine off, 2.9 volts at sea level, good number, right? And then it should be below 1 volt at idle, which we were. You guys think you could test the MAP sensor without my help? Yeah. You just need a little bit of initiative to do it, right? You got a MAP code and you know nothing about the MAP sensor. Do you have a tool in front of you that is a guide? Yeah. Pretty fancy tool. This is the one that really excites me, because a lot of the scan tool stuff we can do, but this stuff is worth its weight in gold. This kind of pinpoint component testing that's unique to a particular vehicle. All right, so we go to shop. What do I want from you guys? Pull the car in, test drive, verify complaint, pull your fault code, look at your code tips on the troubleshooter, find symptom tips on the troubleshooter. If you have a specific component, you think you can handle it, follow your guided component test meter and do some checks under the hood. Okay, and I'll help you, of course. That's what I'm here for. But I want you to be able to do this too on your own. Cool? Yep. Any questions on this car? I think we can let this thing go, don't you think? Maybe if we were in the field, the final thing would be a nice little quick test drive and make sure that we're okay. But I'm definitely comfortable with where we stand.
Here outside the room, 2 days of sitting here inside.
What's that?
2 months of sitting here outside the room and 2 days of sitting here inside the room.
Yeah, and really yesterday we played with this car. We weren't even really addressing the issue. This was, you think about this, if you were working in the field, you could probably have found this problem within 10 minutes of looking at it. As soon as we did our basic checklist, we would have been like, dude, why is that MAP signal changing whenever I open the TPS, open the throttle? So that's pretty cool. Put 2 and 2 together, engine was just swapped, and nice and easy fix. All right, well, you guys just came back from break. I'm just trying to figure out where I'm gonna go next, so just give me a second and we'll address that. Yes, you need your test and you need yours. Just give me 1 second.